In this video, we are looking at a heel hook used in rock climbing and how an understanding of biomechanics can help us in injury prevention. Here we see the calf in action. The ankle joint is a second-class lever which is best suited for movements which involve a lot of force. With the correct warming up, it is an easy job for the calf to hold the lower leg in position. However, injury of the Achilles tendon and the muscle itself could occur if it is put into a position with too much stress or if it lacks flexibility. Once the heel hook is in position and the hamstring contracts, not much weight is supported on the right leg. This is the point where injuries can occur as the hamstring is holding a lot of tension. At the moment, the hands are only being used to balance the body, as the centre of gravity is not in the middle of the climber's body. Now we can see the climber getting into position. Having enough flexibility to meet the demands of the range of motion is needed when bringing the leg up. Overstretching opens up the possibility of injury. Because we understand the forces involved and how they act on the body, coaches can instruct athletes on the correct form to complete the task without injury. The knowledge about the classes of levers in the body will allow athletes to choose the right technique to ascend the wall. Biomechanics allows us to understand human movements and that those movements can be broken down to assess strength and flexibility of the individual. Other methods have been created to analyze movements such as accelerometry and 3D motion capture. Individuals have their own methods of climbing, for example, males and females. It is known that generally males are stronger and females are more flexible. By analysing their performance, we can work out their strengths and weaknesses. Because of biomechanics, we know that in this situation, that longer legs would make it harder to complete the heel hook. This is because the further you get from the axis, in this case the knee, the greater the distance the foot needs to travel to place it onto the hold, which puts more strain onto the hamstring. This results in a stronger and longer contraction needed from the hamstring to pull the body upwards. Improvements can be made by optimizing the position the athlete is in. If the climber in this video tilted his knee outwards slightly, that would take some of the pressure off the hamstring. However, it would mean that another muscle would have to be engaged to compensate. To recap, the levers in the body are designed for different things like force and speed. An injury can occur if there is too much stress on the muscle from force or from lack of flexibility.